Hello, everyone. Welcome to our presentation on International Symposium on Circuits and Systems. We are from University of Glasgow, Magnetic Electronics Lab. Our project is magnetic biosensor for detecting paramagnetic particles of Malaria Hemozoin. Here is a brief introduction of our teams. We have 14 members. Tayaba, who is the leader of our team. Me, Chen, I'm for the technical part of the whole project. Zhehao is for the electronics, and Yinghao is for the programming part. As well as we have two mentors, Semi and Vahid. They provide very necessary support and guidance throughout the project. Now, let's come to the content part. The overview of our presentation. The first part is an introduction and motivation, and the next part is the simulation methodology introduction. The third part is magnetic assisted platform design, followed by execution and experiment results. Finally, we came to the conclusion and possible future works. Now, let's come to the brief introduction of malaria threat. This is the source from WHO database describing countries with indigenous cases in 2000 and their status by 2017. Let's come to the data more specifically. There are 219 million malaria estimated cases around the world, and 18% global decrease in malaria incidence between 2010 and 2017, and 28% estimated decrease in global malaria death between 2010 and 2017. The burden was heaviest in the WHO African region, where an estimated 93% of all malaria deaths occurred, and in children aged under 5 years, who accounted for 61% of all deaths. So, why is magnetic assisted method? Here is a picture from MIT News office, and we can see the table comparison among malaria diagnostics. And we have the techniques of the microscopy, RDT, PCR, MOT, MRR, those traditional methods, and our work. The sensitivity of our work is very sensitive, and the operation time is rather short among the different techniques. And the operation cost is the low price for the device and one test. Unlike other techniques, we do not have the professional skills required. Now we have shown the malaria-infected red blood cells and the structure of the cartridge. The parasites in red blood cells have paramagnetic substances. The blood sample is placed onto a cartridge built of 3 layers. The paramagnetic substances have magnetic moment only in the presence of an applied magnetic field. Paramagnetism in hemozoin arises from the unpaired electrons of the Fe species virus. Let's come to the simulation part. The first picture shows the paramagnetic particles in malaria in red blood cells of the different number of particles. And what's more, in the optimized Hubble array to the maximum biomagnetic field, there are 2 things we do. One is the narrow inner radius, and another one is increase the magnetic field of the each magnets. By applying this structure, we can have a vertical magnetic field to place on the chip. The tuner mag resistance, which is short for TMR sensor, there are 3 different layers. One is the pin layers, which is fixed, and another one is the barrier layer, which is insulator, and the free layer, however, change with the value of the current because the resistance change if the direction of the magnetic field change. Next is our magnetic assisted platform. The first part is the bridge circuit, creating the different voltages, followed by a buffer and a differential amplifier. And after the amplifying process, we have the filtering and converting process. And finally, we can get the interface showing the expected result. And this is the PCB of our readout circuit. This is a graphic user interface where we can see the R value and the impulses from the TMR chip. And this is the platform showing signals from LabVIEW. Once the malaria has been detected, there's an impulse from the picture. The purpose of creating the GUI is that we want to make the entire device lighter, more portable, and more visible. Handheld platform assembly. We place the blood sample cartridge at the center of our model, where we have a 3D printing shell to construct the Habak array cylinder, where we have a port for the Arduino for the screen demonstration. The magnet tube is inside the 3D printing shell. In other words, we optimize the geometry. Now we have come to the experiment setup and execution. We have 4 different concentration samples, from clean water to the large volume samples. And we want to compare their influence on the signals. We completed the final prototype by combining the 3D printed structure, sensors, printed circuit board, and LCD touchscreen, etc., to form a portable malaria diagnosis platform, execute experiment with different concentrations of malaria samples. The final measurement results, where we get the samples result, and after the low pass filter, we can get the smooth result. And this is done by Yinghao Wang. As you can see, this is the smooth result. Finally, we come to our conclusion and future work. I have competed for the numerical simulations for paramagnetic particles in Malaria Hemozoin and optimized the geometry of Habak array. Besides, I was working on the 3-dimensional physical model design and 3D printing. Tayaba, she was working on the analog front-end circuit and data acquisition system design. This project has been intellectually stimulating and continues to push her outside her comfort zone. She looked forward to exploring many such projects soon. Zehao Zhang, he was in charge of writing the code for microcontroller to display visual results and building a graphic user interface for malaria data acquisition by LabVIEW, which allowed him to explore and implement new ideas. Yinghao Wang, he has proposed the acquired time series data for purpose of analysis and enhancement, and improved acquired malaria data using digital filtering. And by this, we work as a very good team. This is our end of our presentation. Thank you for listening.